Welcome to today's lesson. We're going to deal with proportions again, but we're going to be looking at scale drawings, scales, and maps, and how they're all connected with ratios. So go ahead and write this down along with today's date and page number. Come back when you're ready. Okay, so here are two indirect measurement problems I want you to try. The first one is looking at a tower that we don't know how tall it is, but here's the tower. Okay, and we know that the tower here casts a shadow that's 56 feet. And again, H for height, we don't know. But there's a 5-foot tall girl. She's 5 feet tall. And she has a shadow that's 3.5 feet long. So use that information to figure out how tall the tower is. And then for number 2, you have a 50-foot silo. It casts a 10-foot shadow. The barn next to it, we don't know how tall it is, but we do know that it has a 4-foot shadow. So think about this. If the shadow of the barn is smaller, is the barn going to be taller than 50 feet or less than 50 feet? Go ahead and solve those two problems. So you should have found out that the tower is actually 80 feet tall. And you should have found out that the barn is 20 feet tall. Again, my hint that it would have been less than 50 was when I asked you the question about the shadow. All right, now that you got those done, you got your brains warmed up, let's get moving. All right, so we're going to deal with scale drawings and a scale today to figure out some questions. So I have two definitions I'm going to be writing down. The map here shown is a scale drawing. So a scale drawing is a drawing of a real object that is proportionally smaller in this case, sometimes larger, than the real object. Okay, as you can see down here with our scale, which is our second definition, it's a ratio between a set of two measurements. Our scale here says this length, which would be a difference of 1 inch, covers 100 miles. Now, we wouldn't be able to fit the distance between these three cities on a piece of paper if it was 100 miles in its normal fashion, so we scale it down. So when you're reading a map, you got to know how far you're actually going. So on this map, you may go 1 inch, 2 inch, 3 inches, 3.5 inches. What is that in the real world? That's what we're going to work on. So go ahead and write these down before moving on. So here's our first problem I want you to write in your notes. You can see here that it says that it wants us to look at a scale on a map that says that for every 4 inches on the map, that covers 1 mile distance. So on the map, the distance between two towns is 20 inches. What's that actual distance? So what we're trying to solve is the miles part. So you set everything up like a proportion. So remember, our first ratio that we can look at is 4 to 1, inches to miles. Now when you start dealing with two separate measurements, I like to write those in my proportion. That's why I put inches here and miles, so I remember what's on the top and what's in the bottom. Now the rest of the problem, it tells us 20 inches on the map, so that has to go on the top because inches have to match inches, and then miles have to match miles. So since we don't know miles, that becomes x. So from here then, we just find the cross products. 4 times x is 4x, and 20 times 1 is 20. So this is going to be a fairly easy one. To undo the multiplication, we have to divide, and the inverse of, or 4 divided by 4, sorry, is 1, so that just leaves us with x. And 4 goes into 20, which is 5. So on this map, in this scenario, the 20 inches covers 5 miles in the real world. So that's how you use our proportions. Copy this down before moving on. All right, so here's another one I'm going to do for you before we move on to your own terms. So it says here on a scale on a map, 3 inches equals 1 mile. So I'm going to rewrite this real quick as a fraction. 3 inches is a mile. Now on the map, the distance between the two cities is 18 inches. So now I got to determine what's the right part to put the inches to figure out the distance. Well, since it says inches here, and the top is inches, and the top is inches, our inches has to go here. Okay, so we're solving for how many miles that would be in the real world. So we cross multiply. 18 times 1 is 18, and 3 times x is 3x. So inverse operation says that we're going to divide both sides by that coefficient of 3. They're gone. We're left with x. And 3 goes into 18 6 times. So in this scenario, 18 inches is equal to 6 miles. And that's our answer. So another way of seeing me work through the problem. All right, so it looks like for question 1, the scale got cut off when I went to put it on here, and I didn't notice that. So we're going to skip 1 because you don't have anything to reference it. So we're going to look at 4 and 5. So 4 and 5, you're looking at, on the map, California, and you can see Los Angeles is 1.25 inches from Malibu. You got to find the actual distance from Los Angeles to Malibu. The scale to help you is right here. So if you can see that it's 1.25 inches, it's not 2 inches yet, so it's got to be less. So you're going to be looking at dealing with a decimal. I think you'll be fine with that. And the next one says Riverside, California is 50 miles from Los Angeles. So here we have to find out how many inches that would be on the scale. So good luck with those two. Set up your proportions and go ahead and solve them. Start all your proportions based on the scale. So each one of your proportions will start with 1 inch over 20 miles. And then you just have to be able to fill in your inches to your miles. I think I helped you enough to be able to solve those pretty easily. Good luck. All right, so I found, and I hope you found too, that 1.25 inches on this map is 25 miles. And I found that 50 miles on the map then is 2.5 inches or 2.5 inches based on setting up my proportion. You can see for the first one I had 1 to 20 equals 1.25 to x. When you divide by 1, nothing changes, so that's how I got 25 miles. The other one I had to do x over 50, so 1 times 50 was 50 and 20 times x was 20. So I knew it wouldn't go in evenly, so I got a decimal for my answer. Hopefully you got the right answers too. So again, here is a word problem for our example 2 problems. We're dealing with astronomy because it's out of this world. I didn't see you laugh. You should be laughing. Still, I don't see you laughing. All right. I guess it's not funny. If a drawing of the planets was made using the scale, saying for every inch on the drawing, it covered 30 million kilometers. That seems like a huge number, and it really, really is. But when you're dealing with drawings of the solar system, you need to use big numbers, so you make small scales. The distance from Mars to Jupiter on the drawing is 18 3/10 inches. So what's the actual distance between Mars and Jupiter? Well, again, it's easy to set up a proportion because our first part of our ratio is there, 1 inch to 300 million kilometers. So instead of writing 300 million, just write, or 30 million, just write the 30, and then the million next to it. Now, plug and chug on the other side, it gives us 18.3 inches, so we know that we're solving for how many millions. So when I cross multiply, this is another one where it comes out pretty easy. We have 1 times x, which is x, so all you got to do is multiply 30 times 18.3, and that gives you your answer. 30 times 18.3 gives you 549. So the distance between Mars and Jupiter in the real world setting is 549 million kilometers. That's a big number. So I'm going to give you a challenge here to try to earn a 50 from me. When you come to show me your work at the end of this lesson, if you can show me what 549 million kilometers looks like using scientific notation, if it's done correct, you'll get a 50. All right. Let me show you another one just to kind of practice it again. So again, our ratio, our scale is still the same, 1 inch for every 30 million kilometers. This time we're going to look at Earth to Mars. Earth to Mars is about 78 million kilometers, so how many inches would it be? In this scenario, we're just writing the 78 in a different spot of our proportion. You have to do 30 times x, which is 30x, and 78 times 1 is 78. Now, for this one, when I divided both sides, I did 30 by 78. I got 2 with a remainder of 3, and then I just put down, or I simplified it to 2 3/5. Now, what is 2 3/5 as a decimal? You would have a 2.6 if you were to use a calculator or do it with decimals. You probably would have ended up with 2.6 inches, and that would be perfectly fine as an answer as well. So Just figured I'd show you that. All right, I'll save you some time by skipping example to practice and just get you right to the box of thought. So first one, give an example when you would use a scale drawing. Think about our goal. And number two, go ahead and look at that scenario and tell me what you think it would be. All right, here is your quiz. 4 questions. They're all dealing with a map of the Great Lakes, it looks like. And you're going to have to figure out with a ratio of 2 centimeters to 45 kilometers, you're going to find the actual distances of these cities in the Great Lakes area. Detroit to Cleveland, Duluth to Nipigon, Buffalo to Syracuse, and Sault Ste. Marie to Toronto. I don't know if I said all those correctly, but good luck. All right, nice job today. We'll see you next time on Play That Math Video, something like that. See ya.